So this is 1.41, that's negative, in the I hat direction, minus 1.41 in the j hat direction, and that's in meters. Also, for equation 1616, I need the velocity of B and the angular velocity. In this case, that would be either in the positive k hat direction or the negative k hat direction, so I will let the signs take care of themselves and use that to say whether it's clockwise or counterclockwise, but it has to be either positive k hat or negative k hat. And then the last thing I need is the velocity of B. Because I don't know what the angular velocity is, I just know the direction that it's pointing in. To use equation 1616, I will need to say something about the direction of velocity B. So if I knew the angular velocity, I could just plug everything in and that would give me this velocity vector. But, well, let me write my equation down. So I have VA plus the angular velocity crossed with the position of B with respect to A. Because I don't know the angular velocity, I have to know something else. So the velocity of B, that's constrained to move along the slot here. So this is a 30-degree angle. Let's see. I know that if this is moving down, this must be going upwards like this, so that will have a negative I hat component and a positive j hat component. And how about I just say it's the magnitude of the velocity vector times the x component is cosine of 30 degrees, but it's going this way, so it's negative in the I hat direction, plus sine of 30 degrees in the j hat direction. Okay, so using this equation here, since it's a vector equation and we will have I hat and j hat components, it's really like two different equations. And one of those equations will allow us to find the angular velocity, and the other one will allow us to find the velocity of B. How about I do the cross product before I plug everything in? So the angular velocity crossed with the position of B with respect to A, the angular velocity is in the k hat direction, crossed with the position of B with respect to A, that's negative 1.41 I hat minus 1.41 j hat, and the units there are meters. So if I do k hat crossed with I hat, k hat crossed with I hat gives me j hat, so it's minus, because of the negative sign here, omega times 1.41 in the j hat direction, then k hat crossed with j hat gives me negative I hat, but I already had a negative sign there, so that's plus omega times 1.41 I hat. And there should be meters in there somewhere. Let's just stick them in there if you want to keep track of the units. Okay, so now that I have all that, I can go back to equation 1616 and plug everything in. Okay, so we'll do that. And I have VB is VB times negative cosine 30 degrees I hat plus sine of 30 degrees in the j hat direction. This is equal to VA is minus 3 meters per second in the j hat direction plus the cross product, which I have here. That's minus omega times 1.41 meters in the j hat direction plus omega times 1.41 meters in the I hat direction. Now I have my vector equation here. I can look at the I hat and the j hat component separately. So I'm going to look at I hat and j hat. So looking at the I hat components, I have VB times negative cosine of 30 degrees is equal to omega times 1.41 meters. And then looking at the j hat terms, I have VB times sine of 30 degrees, whoops, sine of 30 degrees minus 3 meters per second minus omega times 1.41 meters. Okay, now, did it ask me to find omega? Determine the velocity of the peg. Okay, so I don't have to find omega. Maybe I'll want to find it anyways. But by looking at what I have here, omega times 4.1 meters is equal to VB times negative cosine of 30 degrees. So I can take this and replace it with what I have here. So then I have VB times sine of 30 degrees is equal to minus 3 meters per second. And this would be, it would be negative, but this is also negative. So let's say plus VB times cosine of 30 degrees. So if I bring this over to the other side, I have VB, this is sine of 30 degrees minus cosine of 30 degrees is equal to negative 3 meters per second. So finally, I have EB is equal to negative 3 meters per second divided by sine of 30 degrees minus cosine of 30 degrees. And if I did everything correctly, this should be 8.197 meters per second. And that would be going in the, oh, that would just be the magnitude. What did they ask us to find? Determine the velocity of the peg. Oh, well, that would be along this line here. That would be going this way. We could write it in vector form if we wanted to. We could take this and put it back in here. But let's just say 8.197 meters per second. And then if you wanted to find the angular velocity, you could go back to this equation here in order to do that. Let's see, if you want to do it on your own, you should find that the angular velocity is 5.02 radians per second. And if you go back and you look at the diagram that they have here, if the peg is moving this way, then the angular velocity would be like this. So this should actually come out to be negative. And I may have rounded a little, so you might actually get 5.03.